Today, rational exponents. Mr. Todd, I know what exponents are, and I think I've heard that word rational before, but I don't remember what it is. I'm going to really get to the bottom of rational. Now, let's just talk about what a rational number is. We'll start there, and then once you know what a rational number is, then you'll get scared. After that, you'll be like, wait a minute, rational exponent? What are you going to do here? Okay, but anyways, for now, first part of the lesson, let's just talk about what is a rational number and how does it apply to exponents. We'll do after that. Yeah. What is, what a great preview I did. There it is. What is a rational number? A rational number is any number that can, oh, most important word in the sentence. You highlighter people, I hope I'm getting through to some of you to be highlighter people. PowerPoint doesn't highlight all that great, but I'm going to highlight can. Because there's lots of numbers that don't look like this, don't look like a fraction. They don't look like a over b, but they could be written like that. My best example for that, and I'm going to switch to the other pointer here, pen, and I need a great color here. I'll use yellow. For instance, the number 5 is a rational number, but it doesn't look like it. How could I write 5 as a fraction that's a over b?
Like 5 over 1.
5 over 1. So that's what that word in there. It looks like tricky. Like, well, what do you mean can be expressed? You trying to trick us here? No. I'm just trying to say there's lots of numbers out there that are actually rationals, but they might not look like it at first. You can make them rational.
Don't like all numbers divided by 1 equal like same?
Perfect question. I'm going to get to it in just a minute. We're going to play a little game called Rational or Not, and then we're going to bend your brain a little bit about how could a number not be rational. You may not realize that the question you're asking is, aren't all numbers rational? Isn't every number able to be expressed as a fraction? Well, we better talk about that. Be clear on what the rules are for the game today. So, let's see if I got the volume right. I think there's sound here today. We'll see. Yeah, there we go. Game show time. Rational or not. And we're going to go through a bunch of numbers and make sure we understand which ones are rational or not. Yeah? 3 over 5. Hopefully that's the easiest one on the list. Is this number a over b? Does it look like a fraction? Yeah. So that's the easiest one so far. That's what we're talking about today. That's when the fear starts. You're like, wait a minute. You said this is going to be rational exponents. You're telling me you're going to take 3/5 and make an exponent? Yes. I'll tell you when to do your seatbelt up. It's going to get interesting what to do with rational exponents. But this is what we're talking about, fractions. You say a rational is a fraction? Pretty much. So 3/5, definitely a rational number because it looks just like that. It looks like a over b. It just has that representation. Negative 1.5, okay. Doesn't look like a over b, but back to this word, the most important word in the sentence. Can you express negative 1.5 as a fraction? And the answer is yes. What fraction would it be? What fraction? We might need that today. We better. Oh, I don't know what just happened. Went into presentation mode. Do, screen. Oh. Hide presenter view, good. Pointer options, pen. And ink color, yellow. Okay, good. Now I can write. Now I can get what I want. I gave you time to think about it. What fraction is negative 1.5? It's a hard one.
Oh. Wait, is it like 3 over negative 2?
Yes. Or you could do negative 3 over 2.
That works.
Or you could do negative 3 over 2, any of those. 3/2 is what we're talking about. Not a whole lot of that today. You're like, oh, this is the part I don't like about fractions. Not a whole lot of that today. Just mentioning 1.5 could be expressed as a fraction. What about 182?
No.
Could you express that as a over b as a fraction. Yes, I could just put that over 1, just like I did there. That one also could be a rational number. These are what rational numbers are. Anything that could be made into a fraction. Isn't everything a fraction? No. -9. Oh, -9 is. -9 is fine. We saw that as an exponent yesterday. You could put that over 1 and make it into a fraction. Let me put those over top, just in case you're really getting stressed about this. See, those are all can be expressed as fraction.
No.
0. Does the 0 over 1 thing work? Is 0 over 1 the same as 0?
No.
Why not?
Oh, I just think like 4 of them are rational, so I assume.
He's going with the, you're setting up for something there, Miss Todd. You're up to something. This one survives the test. 0 over 1. That's a fraction.
That's still 0. Oh.
It still has value 0, so it's okay. And you're right to be scared of 0. You felt in the previous lessons. There's a problem with 0, but it's only if it's in the denominator. Here it's fine. All right.
Yes.
Root 2. Well, there's been lots of discussion over that over the centuries. So if my explanation is not good enough for you about this number, that's okay. That's okay. We're not going to get carried away with it. But technically speaking, root 2, there's no fraction out there that can be root 2. They studied it for centuries. Mathematicians went, we don't think that there is a fraction that equals root 2. We don't think there's a fraction you can type in your calculator, a divided by b, that comes out to the same decimals as root 2 does. They were sure it wasn't true, but it took them centuries to actually be able to prove it. And when the proof came along, it was actually a pretty simple proof. You could look it up tonight. I don't want to distract from you right now, but you could look up, is root 2 rational? And it's about 7 lines of algebra when they finally figured it out, and it proves, without a shadow of a doubt, there is no fraction you can come up with. That is, let's say we had a perfect calculator. A perfect calculator, we press equals, and it does the decimals all the way out to Pluto. Yeah, you could walk, you could go on your spaceship, and you could look at all the decimals all the way to Pluto. And you typed in root 2. And I typed in a fraction that I thought was the same. Somewhere along the way, the digits will change. You might be able to come up with one that does 10 digits, 12 digits, 14 digits of root 2, but somewhere along the way it won't match up. Scary math. Like scary. And if you read the proof, you're like, this really scares me. Yeah, it took a long time. It took centuries for them to come up with that root 2, not rational. You don't have to memorize that for the test. That's not testable material. I'm just trying to mention that there are some things that aren't fractions. Today we'll only be dealing with ones that could be fractions. Here's another one. Pi. For centuries they believed, I might be exaggerating that a little bit, for a long time they believed that 22 over 7 was pi. So if we put that in your calculator, if you have your calculator there, punch it in and see what you get. 22 divided by 7. (22 divided by 7).
Wait, but it's not.
It's not. It goes 3.14285. But pi is 3.14159. Yeah? So you're like, I can do it. I'll come up with a better fraction. Mathematicians have proven that no matter what fraction you come up with, eventually there'll be a difference in the decimals. It can't possibly be done. The proof that pi is irrational, you could read the root 2 one. If you read it 4 or 5 times, spend an hour on it, you'd be like, I understand that proof. This proof, whoa, crazy stuff.
Wait, what if you just do like 3.14, like whatever, a bunch of numbers, over 1? What if you just do pi over 1?
Yeah.
It's still the same.
Yeah, I'm with you.
So it is
Okay.
rational.
No.
What? Oh, yeah, my bad.
A and B have to be integers. So by using pi in the numerator, you're not using an integer. So it has to be integer whole number. You have to be able to use 2 whole numbers. But you're right, and they searched for a long time. They went, okay, not 22 over 7, how about 221 over 71? How about, and they just kept going and kept going. And eventually, if they calculated it out, eventually the decimals would be different. I can't even imagine the work that took without a calculator. The work must have been horrendous. Well, it was just long division, but it went on all day. This is what they worked on.
How's 0.5 a number then? Like if you could do
1 over 2. Both The top and bottom are integers. Great questions. They're the perfect questions. They're the perfect questions for the situation. Go, wait a minute, I think it can be done. No, these two you can't. And that's not really part of today's lesson. This is me nerding out a little bit on you. Yeah? I could have skipped this slide and said, what we're going to talk about today is what happens if the exponent is like a fraction like that, and then started the lesson. That would have been another way to present it. But especially since we have AP people in the room, I want to mention there's more than meets the eye to this. There's lots going on here. There's lots of math to know and learn. In my head, I can do this proof. In my head, I don't think I remember this proof. So it gives you an idea of the limitations that I have as well. In my head, I can do this one. If I look that up, I'd be able to follow it. Where you're at with grade 11, and this isn't, maybe you'll turn out to be a better mathematician than me. Where you're at, you probably have trouble following this one. And this would be like gibberish. You're like, what are you doing? Yeah. There's a couple of tidy proofs. So root 2 and pi are out. We won't see those as exponents. You don't have to worry about all that. Again, if after this slide all you realize is, so we're talking about fractions today? Is that what's going on? That's good enough. That's a good first slide. So rational exponents. What does 4 to the 1/2 mean? Let's go back and just do something simple. Something simple and go, what if I had 4 to the exponent 1/2, what can that possibly mean? What can it mean to go 4 and multiply by itself 1/2 times?
It 2. Like, wait, 1/2 times. Hold on.
Yeah.
So you're timesing it by 1 and then by 0.5?
I'm taking 4 and multiplying it by itself a half a time.
Oh, so it goes less, right? It's division.
Oh, it's smaller. It's going to be smaller than 4. It's going to be smaller than 4.
So
Okay?
2.
Let me do 2 slides to try to, after the 2 slides, you might be able to go. Okay? Let me do 2 slides. 4 to the 1/2. Here's my investigation. Very clever investigation. I don't take credit for it. I'm not saying, oh, Mr. Todd thought it's a clever investigation. This is a very clever way to understand what that 1/2 actually means. It's actually real nice. Once you see it, you'll be like, oh, well, that's easy. I can do that. Okay, here it comes. If I took 4 to the 1/2, the thing I want to figure out here, and multiplied it by itself, something awesome happens. Because we know the exponent law here. Add the exponent. What's a half plus a half? A whole. So 4 to the 1/2 times 4 to the 1/2 is 4 to the 1. So hold on. Big moment. Whatever 4 to the 1/2 is, when I multiply it by itself, I get 4. I'm trying to figure out what 4 to the 1/2 is. I don't know the answer. But I know that if I take the answer and multiply itself by itself, I get 4. So what does each of these have to be to get answer 4? 2. They both got to be 2. This has to be a 2, and that has to be a 2 for it to be 2 times 2 equals 4. Just pause for questions.
Okay, then can I just okay, how do I explain this? Whatever the fraction is as the exponent, can I just divide the number that it by the...
Almost. You're right on the edge of it. Give me one more slide. Wait to see the next slide. Because the first example, there's all sorts of possibilities about what actually might be happening here. The second slide will narrow it down. Okay? Remember this, though. The 1/2, what I did is said, okay, what if I multiply it by itself? And if I multiply it by itself, I get the 4. That makes it easier. Then I was able to go, okay, each of these 4 to the 1/2, they must be the same. It's got to be the same thing multiplied by itself equals 4. And the only number that does that is 2. 4 to the 1/2 equals 2. Remember that. And then we'll do another slide of investigation. And after that slide, we might be ready to go, oh, it's just this. And it is. It's actually a pretty simple conclusion. I don't want you to think after all this crazy talk that there's some crazy math thing coming out of this. There's not. It's pretty nice, what comes out of it. Yeah? Do you need more time to write that one down? Did you see who's up in the corner here? Detective. We're doing investigations here. We're trying to see. So he's doing the right thing. He's going, what's going on? What's going on? What's going on? But I think you really do need the second slide to really be able to get it. So I'm going to go to after a tougher one this time, okay? Do you need more time here? What does 8 to the 1/3 mean? I think the last one was pretty easy. Used 4 as the base, and I only used 1/2 there. This time it's going to be 8 to the 1/3. But I'm going to use the same trick that I did a second ago. I'm going to go, okay, I don't know what 8 to the 1/3 is. But if I take 8 to the 1/3 and I multiply it by itself, biggest moment of the lesson right here, then by itself again, I can use my exponent laws. My exponent laws say add up all those exponents. What's 1/3 plus 1/3 plus 1/3? That's a whole. And I get the 8. Now I've got something to work with. Now hold on. If we're going to really understand what's happening here, what was different about this question? That I needed 3 of them, and in the other one, I only needed 2 of them. That's the key to the whole lesson. That's the real deep understanding there. What was it about the fraction with the last one, where I only needed 2 of them, but this time I needed 3 of them?
Wait, it's the denominator.
It's the denominator. The denominator's key here. It's key. When it was 1/2, and I'm coming back to it in a second, when it was 1/2, 2 of them was enough. When it was 1/3, it took 3 of them multiplied together to get something nice. When you saw the 8, you're like, oh, 8. Whew! I know what 8 is. But now the answer to the question is, I'm looking for a number that I multiply it by itself, then by itself again to give 8. Now, we'll just let that bounce around your head for a second. What number do you multiply by itself, then by itself again to get 8? And I've chosen nice numbers here on purpose.
2.
It's 2. 8 to the 1/3 must be 2.
Oh.
A little creepy, that voice, was it? Oh. I'm going to go, and then I want to hear from what you have to say, okay? Both of the slides, the answer was 2. Oh, the homework's always going to be 2. It's always 2. No. I tried to make the simplest ones I could think of, and they both came out to 2. So, what am I looking for? When that's a 2, I was looking for 2 numbers multiplied together. I'm right on top of a word here. If you know what the word is, I need it. I need the word. When it was 3 of them, I needed 3 things multiplied together. Close actually. If I have something multiplied by itself, and I want to know what it is, what operation am I using? It's squared. To undo squaring, square root. Square roots on the bench here. If I'm the coach of the math team, the square roots on the bench going, put me in, I can do these. This is square root. That's what 1/2 is. So what's 1/3 then? Cube root. You're like, oh, I didn't even see what cube root? What are you talking about, cube root? Oh, it's calculator time. Your calculator's ready for this. It's not surprised by this situation at all. We did a lot of Pythagorean theorem. We did a lot of squaring, that kind of stuff. So you're used of square root, but we can do any root you want. Let me get my calculator on the screen, and let's talk about rooting. Yo!
What if it's not like 1/.
Oh, yeah. That's a slide coming up, buddy. One of the slides coming up says, what if it's not a 1 up there? So let's just get 1 narrowed down, then we'll deal with other numbers in a second. You're asking the exact right question. Calculator, I don't know on your calculator what it's going to be. This is the old get to know your calculator thing, right? Mrs. Todd says, take your calculator, put it under your pillow every night, keep it around so you know what your calculator can do and how it can do it. You don't want to borrow someone's calculator anymore. That's not a thing. And if someone asks to borrow your calculator, you're looking at them like, what are you going to do with it? You're like, I'll write my test, I'll bring it right back. All right, you bring it right back. Yeah? You've got your calculator's your new best friend. Okay, we know what square root is. Let's do a couple of square roots, just to bore you a little bit. But listen to what I say. It's not as easy as a grade 9. We got to think about what this means. If I do square root 25, what's the answer? 5. Because 5 times 5 is 25. There's 2 of them multiplied together. Okay? Square root 100, another easy one. 10, because 10 times 10 is 100. You're literally finding the square root. Hold on. When I say square root, I mean square root. Here, hold on. Here's the question I just did. I need a square. A square. This is a square. Area equals 100. What's the side length if the area is 100? 10. It's the square root. It's the side of the square. That's why it was called square root. You're finding the root of the square. You're finding the base of the square. If I was inventing it hundreds of years ago, I wouldn't have called it square root. I would have called it square side. Yeah? That's a better name for describing what's going on here. You're finding the side of the square. Stick with me. Stick with me. All the brain power right now. If you didn't have your snack, well, you're stupid. But you should have. You should have had your snack for extra brain power here right now. We'll do one more. One more that most people know. I don't know why people know this one. Square root of 36? 6. Because 6 times 6 is 36. Two of them together. We're good with square roots? We went back and practiced square roots. Square roots. Now what you need to understand about square roots is technically, this messes people up. When you write square root of 100, there's actually a 2 there. Rocking your world. The regular square root symbol has a 2 there. We don't write it. It's saying take the square root. 2. Yes? There are other roots available. Let's do a different one. Let's do this. Volume equals 27. It's a cube. How long is each side? The most important thing I've done so far is see my hand going one side, two sides, three sides now. See? It's not square root, cube root. What are the sides? I chose a nice number on purpose. What if it's not a nice number? Oh, hold on. I'm here all day. You know, I'm going to get through it all. But what are the sides if it's going to go times itself again to end up with 27?
3.
He says 3. And he says it with a slight question in his voice, which was perfect. Let's check it. 3 by 3 is 9. Times 3 is 27. That's fine. That's fine. But then the blaring question should be, well, that's great, Mr. Todd, but what if it's this cube? Volume equals 715. You're like, cube root. Cube root. Find the side of the cube. Okay, to the calculator. I forget how much. Oh, there's the AP Calculus calculator. We don't want that. Get out of there. We want this calculator. Cube root. Mine has a cube root button. I can see it just barely. Yours might have a root with a little 3 in front of it. So let's try it out. I'll try it on mine. If you don't have a cube root button, it's okay. I'm going to show you how to do any kind of root. Mine actually comes up with cube root 27. What are you expecting to see? 3. It does cube roots, or whatever root you want. Mine has an X root button. It's like, oh, you don't want cube root? You want 17th root or whatever you want? Then I can go say, oops, I got to press the number first on mine. I got to go cube root, and see, mine puts the 3 up there. Yours might not. It might put the 3 outside the root, which might make you angry. You're like, calculator, no, the 3 goes in the root, like in the radical there. Did you call them radicals yet? Tomorrow I'll start calling them radicals. This is radical, dude. All right. Cube root 27 equals 3. So we can now do any root we want. Okay. Woo, that was a major sidetrack. Back to here, where were we? Where were we? If, yep. Exciting, thank you. Exciting, pi, super. To do 4 to the 1/2, we're going to have to do square root of 4. That's the part I warned you about. No, warned you about. Tried to inspire you about going, once we figure out what's going on here, it won't actually be that complicated. To do 4 to the 1/2, we're going to do square root of 4. You can write this in your notes. Go back to that spot. I'll go to my pen and go to my yellow. I'm taking my time here, making sure this is very clear. Square root of 4. There's technically a 2 there. When you write a regular square root like that, you mean 2. That's weird. That's new and weird. But when you did 8 to the 1/3, we would do, I'm going to do it wrong, okay? You tell me what to do. What root are we doing now if this is a 3? 3, the third root. Sometimes called the cube root, but you can also call it third root. Ms. Todd, I slept through all that. Can you tell me what's happening? Someone comes in late right now. Ms. Todd, what's happened so far? We found out whatever this denominator is the root number. Some people wish I would teach like that, don't they? Can you just tell us what to do? It doesn't work. It works for a while. If I just tell you what to do. It works for so many periods or so many classes, or so many grades. And at some point, I don't understand what I'm doing. I can't memorize it all anymore. Yeah? But I'm on to a conclusion here. I'm very close to a conclusion which says whatever the denominator is, that's the root number. Party's over. If I can't do it in my head, my calculator can handle it. That might be the whole lesson so far. But do you have questions? There's what I wrote on the other slide. You can recopy it down if you want, or you can be like, yeah, I got that. I liked the way you presented it before, but here it is in words. This expression is called the third root of 8 or the cube root of 8. This is still called square root. You don't often hear people say the second root of 4, but it is. It's the second root of 4. Cube root 8 is the number 8 that gives 8 when multiplied by itself 3 times. I had someone argue with this one year and said, well, technically you're multiplying it by itself 2 times. You're taking the number and multiplying it by itself 2 times. I get that technicality. It means you got 3 of these numbers in a row. 2, 2, 2. Multiplied together gives 8. Should you do them in your head? No, I don't think so. Maybe a few. There's a few cube roots maybe you can do in your head. How many square roots did we did? We did square root of 36, square root of 25, square root of 100. We did a few. Like, it's nice to have a few in your head. But mostly speaking, you're like, calculator, cube root, thank you very much. You're going to love your cube root button. Finding the cube root of a number is the inverse operation of cubing. So we're uncubing this thing. You saw in the pictures, I drew a cube, and then I was taking away the cube and going, what's the side? I'm finding the root of the whole thing. Give you a minute to copy down what you want from there, which parts you need, while I try and protect my voice a little bit. What questions do you have? Questions? More time here? Give you all the time you want. More time to copy this down? Yes, more time. Yeah. I've got On the Ball on the website, and I'm posting a PDF the day before. So if you want a skeleton of the lesson, you could print out the note beforehand and get some of the notes already filled in for you, and you could just fill in the gaps. Some people don't like that. I don't suggest it for everybody. Some people like the copying out is their learning. It really works well for them. But if you want a little less writing, the PDF will be there the day before. You could go there and print it out and save yourself a little bit of writing if you wanted to. Extending your knowledge. You're like, extending my knowledge? I want to extend. I don't know if this is really extending. It's like practicing. 36 to the 1/2. What do I do with that 1/2 now? Now that we've seen it in action, what does the 1/2 become? Square root. So 36 to the 1/2 is square root 36. Now you've got something to do. You can go, okay, square root 36. Can you do them in your head? Well, I hope you can do some of them in your head. But you just go to your calculator and hit root 36 and you get answer 6. So it looks weird. I know. It looks weird, this transformation. To go from 1/2 to square, it looks weird. But actually not too complicated today when you actually get down to the bottom of what's happening here. 27 to the 1/3. What root number does 1/3 become? So I mean, anytime you see a fraction, a rational number up there, you're thinking, oh, this is a root, actually. It's technically a root. What root is it? 3. So it's the 3rd root, or the cube root if you want. Can we do this one in our head? Well, you try them in your head. Cube root of 27? 3. You'll get to know, we use a lot of the same questions. They have the same cubes keep coming up again and again. But again, your calculator does cube root. Might have a direct button, might have to use the X root button. That Casio one we're talking about, does it have its own cube root button?
Yeah, so if you click shift and then you go up here. So
Oh, it's even better.
regularly.
Oh, it looks good on the Casio one. This is why we like that Casio calculator. The buttons look good. They like scream at you. Me, I'm the cube root button. You can really tell when you look at it. If you got a different calculator and you can't find it yet, just come and talk to me. I'll figure it out. Every calculator I saw so far will do what we're talking about. Okay, here we go. 81 to the 1/4. Don't let it intimidate you. Don't let the numbers intimidate you. Just go, what do I do with these numbers? What does the 4 become? Where does it go? 4th root. It goes inside this thing, which tomorrow I'll start calling a radical. You know, this piece here, I'll start calling this a radical, but I use that word now to get you ready. It's now the 4th root 81. Can you do that one in your head? Oh, I don't know. You'll need your X root button in your calculator maybe. But can we do it? 4th root, something times itself again gives 81. It's really a pair of 9s, isn't it? 9 and 9. What multiplies by itself to give 9 is 3. So maybe you could sometimes approach them. I'm not suggesting that we're not about memorizing them. We're about punching it in our calculator. Do right now. See if you can find 4th root. Find that X root button. Hit the 4, hit the X root, or X root then 4. I don't know which way around it is in your calculator. And what do you get? Somebody on their calculator, 4th root of 81? 3. For today, we'll keep the numbers under control. You see how the numbers keep coming out, 2 and 3 and 4 and 5. We're not trying to torture you with these just yet. In just a minute, I'll torture you, but the calculator's going to take away all the torture anyway, so that's not really a big problem. This is called the 4th root. You might want to add that to your note. As point at that and go, how do we say this? It's the 4th root. And the next one's called the 5th root and the 6th root. What do they actually mean? Oh, it's going to take some time to understand why 4th root comes up. Because cube root was a cube. 4th root, what's that the root of? You got a shape for that, Mr. Todd? It's a 4D cube in 4 space. No, way off in the future, before we can actually picture it. Yeah. Oh. And we keep going. 32 to the 1/5. What root number? 5. Don't let the numbers intimidate you because you don't have to memorize these. But can we? I chose nice numbers on this first one. 5th through the 32. What do you multiply by itself to end up with 32? Here's how I do them if I'm going to try and do them in my head. I just start checking the numbers. Is it 2? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. A lot of the homework ones are nice like that. You'll just find out it's like 2 or 3 or 4. But again, try it in your calculator. Make sure you can find in your calculator your X root button. Hit 5, then that root button. Or that root button, then 5. However it works in your calculator. You got to play with it a couple times. And find the 5th root of 32. That one's called the 5th root of 32. Any questions? Well, here's a question you could ask. You're like, okay, so Mr. Todd, you've been teaching for how many minutes here now? What time did you get here? 10:25? Mr. Todd, you've been at it half an hour. And all you've really said is whatever number is in the denominator, turn that into the root number. To which I say, yeah, not a bad lesson, actually. So make sure, don't complain when it's simple, and also complain when it's difficult. You know what I mean? Like this, it might be difficult, but it's really simple if you know what to do. As long as you have on your study page, and that's what I was working with the AP Calculus people, making a nice study page for the things they have to know for their test, but your study page might just have on it something that you'll see on the next slide here. It's coming up. Here, oh no, here it is right here. In general, here's the one you want. You didn't copy down anything else today? Get this sentence down. In general, if you got a to the 1 over n, and your question's coming right up here, what if it's not a 1? But it's not bad. There it is. There's the whole day in a nutshell. If you know what this means, that's the whole lesson so far. A to the 1 over n turned into nth root of a, and let your calculator take you home. Not bad. Not bad for a Tuesday. Is it Tuesday? But it's only a 4-day week for you guys, right? So it's sort of like Wednesday for you guys. Yeah, because you guys are PA day in the second week. Jeez.
Don't you still have to go to school though?
Yeah. It's going to be awesome. Let me tell you. PA days are tremendous. Do you have questions here? Did you get this? If you got nothing else, get this. That gets the red box for you highlighter people. Don't be shy. I've got highlighters. You're like, Mr. Todd, I really want to be a highlighter person. Do you have any highlighters for me? And I'll give you a set of 4 highlighters and you can have them. Whoever you are. I know you're out there. I know some people are like, this is perfect. I'm going to highlight everything all the time. This is called the nth root. Yeah, you really use that. I don't mean nth root. I mean, it'll be called the 4th or the 5th or the 6th or the 7th or the 8th, whatever the number is, nth root of 8. Do you have questions? You need more time? Do you see the shirt I wore for you today?
That's
Oh,
all
what?
from the book that you showed us.
1, this is you doing algebra. But 2, this is also now in grade 11 you doing life. Yes? Mr. Todd, how do I keep track of all this stuff? I went from being a kid to being an adult like on Labor Day this year. I'm like, yeah, no, sorry. We protected you as long as we could. Actually, the Ontario curriculum is pretty good like that. It protects you for 10 grades. And then 11th, like, we can't protect you anymore. You want to go to university or college, we gotta take it up a notch. Don't worry, it'll get worse. Yeah? Grade 12 will be a lot more complicated. University or college will be like crazy busy. Then wait till you see what happens then. Spouses, houses, vehicles, gas bills, insurance, floods, locusts. No, not locusts, but things are going to go wild. Yeah? So it's okay. Don't worry. You'll be ready when the time comes. Ooh, try these. Oh, try these. Not bad. Okay? You're going to try these while I do attendance. Huh? Not bad. Not bad, actually. Not bad. Got to think a little bit.
Hey, yo, is that a negative?
Really?
Oh. Give them a try.
Somebody tells me it's the same thing though, 'cause they're both negatives.
Oh, you just put it on. You know what?
Yeah, it might be okay. It might be okay. 5 whole minutes to try those 4. I'm lying. I'm not going to do attendance. I'm just going to chill out for 5 minutes. Those of you on the video, you can fast forward. I set a timer, so you can fast forward 5 full minutes. Or you can pause the video, try these out, then check in. Let's not wait till you do the homework to find out this is difficult for you. Try them right now.
Why are you asking me? Just ask me from what university, so. I'm sure you're not stupid.
Incidentally, your calculator is really smart. So if you have trouble with these, I'm going to show you how to get your calculator to give you a hint. Your calculator can help here. That was lucky.
What's the difference if it's in brackets?
In this particular case, that 1/3, the cube root would come out in front of the negative 27. Here it would just come out in front of the 27. Yeah.
One over -2. Yeah, that's right. Liam, it's not
Oh. Is it 81?
It's -1/2. Think about it. It's -2. Did you do your homework last night?
Ha ha ha. Oh, what a great sentence. I don't know who was speaking to who. Did you do your homework last night? No, you didn't, did you? Yeah, it's good. It's good. I like that. Let's get the peer pressure going in the opposite way. Grade 10 is like, peer pressure was, you did your homework, you nerd. This year it's like, you got to do your homework, man.
Yeah.
Yeah.
I did my homework and I'm glad.
But I had hockey last night. I don't care. I don't care. I played hockey. My kids played hockey. My students last year played hockey. Swimmers. Swimmers get a little tiny bit of sympathy from me. Every other sport gets none. No, dancers a little bit. I know dancing gets busy. Swimming's insane.
Mr. Todd, please tell me you can solve that.
I can. Oh yeah. It'll take a while.
Show through.
One of the reasons I bring these is to keep me from harassing you when I'm supposed to give you a little bit of work time. So it just keeps me from like keeping to make stupid jokes and bothering you. So this one takes a while just to mess up.
Yeah.
You see how it's got a lot of patterns still in there, so it's
I
going to take.
solved the Rubik's Cube before. I used a YouTube video, but I still did it.
That's all right. I can show you some tricks.
There's a bunch of different stuff you have to do.
If you want to relearn it, buy yourself a 2x2.
Okay.
There's so much that can be learned from the 2x2.
Yeah.
It's good progress to practice on a 2x2. I still practice the 2x2 sometimes.
Yeah. I can easily solve like the one side of the Rubik's Cube. That's,
Right.
That's
Right. So then to finish a 2x2, you just need 2 more moves.
Yeah.
They're called algorithms, but you can just call them moves. I need a couple of moves here. And the moves allow you to move things around without messing up what you already have. That's the big challenge that you're going to have. And sometimes we understand what the algorithms are doing, and sometimes we don't. We just have to memorize them. But both are fun, depending on your definition of fun, I guess. 7 seconds. But I'm not done. That's okay. We're going to take them up. Okay, there's timer's up. Tell me. Okay. First one should be, hopefully my lesson, if my lesson was any good, first one should be pretty good. What does the 2 become? So square root. This is square root 49. And you don't have to write the 2 in the radical, but you could. Starting now, you can give your grade 9 friends a little bit of attitude when they write square root. You're like, oh, you guys don't write the 2 in there, do you? Oh, yeah, well, you'll learn. Yeah? So square root 49 or square root 49, like that. Then you can do it, either in your head or you jam it in your calculator. At least you know what to do. Okay. Negative 27 to the 1/3. What root number? I know, it's a 1 up there. What if it's not a 1? If it's not a 1, don't worry. Don't worry about that. I'll be able to fix that in just a second. But if it is a 1, what root number? 3. Cube root negative 27, which might bend your brain. Because something might kick in. You're like, no, you can't root negatives. You say, teachers say in 9, no rooting negatives. I'm like, can't square root them. But you can cube root them because now it's an odd exponent. A number times itself again, that comes out to 27, negative 3. And your calculator knows, it'll be okay. But this one's a little different. And this is annoying. If you're annoyed by this, I'm with you. I'm totally with you. Because the 1/3, we do, due to bed mass, we do exponents first. So this is like that. That's a little bit different, but gives the same answer. But technically speaking, that cube root only goes on the 27, not on the negative, because the negative's not in brackets. And it's because of bedmass. Exponents go first. Exponents take over. Be annoyed. That one's annoying. Now I need someone who did their homework last night to go, what do I do? This negative. I say deal with negative exponents straight up. What do you do with the negative?
He's got it. He said he did his homework.
All right, so what do you do?
Tell him, Carter. Tell him.
All right, so you have to get the negative power. So you have to put 1 over negative 8 to the power of 1/3.
Okay, listen. If you didn't do your homework, or you did do your homework and didn't know that, that's one of those things that's going to, be the, I forget, he actually ends up falling down, Cat in the Hat, in the next page. He does one extra thing. I forget, so he fans with the fan, or something like that. That move right there is the one that might be one too many when you're doing these questions. And those of you who had trouble with homework last night, that might be the one that messed you up time and time again. Negative exponents, they bend the brain. They're completely annoying. And yet, if you know the trick, it's no big deal. You take the negative exponent, you move whatever it is you're talking about down to the denominator, and now it's not a negative exponent anymore. You're like, whew, that's good. So I think that's first. Get rid of that negative exponent. Then life gets easier. Now it's cube root of negative 8. I got ahead of myself there. And what's the cube root of negative 8? I know what your brain does. You're like, but you can't root negatives. Yes, you can cube root them. You can't square root them. I'm not changing the rules. Up till before today, all you had was square root. But you can cube root negative 8, and you get negative 2. It's not wrong to write it like that. We usually write the negative out front or on top. We'll just find it more convenient to be there. But none of these are wrong or right. These are just probably easier to work with in future examples. Okay? All right. Do you have questions about that? Used 5 minutes of valuable time, but I hope it was good for you to go, okay, sort of got the gist of it here. What if the number isn't 1? The PowerPoint's laughing like this is really difficult. It's not really a big problem. If it's a number different than 1, it's okay. Oh, I wrote on it. Can you see it? 9 to the 3 halves. I'll write it underneath here. 9 to the 3 halves. Don't stress. I know some math lessons, and I'll teach you some math lessons, that right about this moment in the lesson, I think it happened yesterday, right late in the lesson, it's like, oh, now here's a tough one. I don't think this is tough at all. I think this is not a problem. Here's what you got to do. When you see 9 to the 3 halves, write it like this. You're like, you cheater, you can't just write 1/2 like that. I'm like, I really can. I'm going to use one of your exponent laws, and I'm going to take the numerator, that exponent, and put it out here. That's all. That's all. Rest will be easy. Then I go, hold on. Now it's power of a power. I'm like, I know, look, power of a power. What's 3 times a half? 3 halves. It's okay. You can totally take the numerator and put it up there for a second while you think for a second and go, I'll deal with the numerator in a second. Now 9 to the 1/2, you can do that, square root 9. But when I'm done, I got to cube it. That's okay. And I get 3 cubed, which is 27. I did that a little fast on purpose to try to encourage you that having a numerator there is no problem. It's an extra step. Put the numerator up as a power and deal with it at the end. Shouldn't be too bad. Shouldn't be too bad. Hard, after a long lesson like this, your brain starts to get a little wobbly, especially if you haven't eaten enough today. But not too bad, actually, when you go back to look at it. Oh, what a mess. I'm going to have to clean this up. I got carried away. Hold on. You already got this? So I can erase this now? All right. Where's my eraser? Pointer. Eraser. Now back to pen. Good. Okay, here's 2 more examples. 8 to the 4/3. I'll put B right here. And I'll try and fit them all in. 8 to the 4/3. What do you do with the 4? just put it up as an exponent. 8 to the 1/3 to the 4. Then 8 to the 1/3, we've done that a couple times already. That's cube root 8 to the 4, which is 2 to the 4, which is 16. You let me know if I'm going too fast. I'm not trying to rush it. I was hoping that when we got to this one that you're like, oh, well, that's not so bad. Put the 4 outside, and then you do what you did before. But you're just going to have to deal with that 4 at the end. In fact, some people get so good at it, and I'll do C a little bit differently. Some people jump to here. Here's what they do. They go negative 27 to 2/3, and they jump right to here. They go, oh, that's cube root negative 27, and I know I'm going to have to square it afterwards. Some people, after practicing it a few times, like a couple of questions, they go, I already know what's going to happen here. I don't have to move it up beforehand. I know what's going to happen. Do the cube root of negative 27, and then I just have to square it at the end. Should you be there now? No, I'm not trying to rush the lesson. I'm trying to say, when that happens to you, when you're doing the homework and say, I'm just going to put it up there now, yeah, that's a good thing. It means you've practiced it enough. Cube root negative 27, you check your calculator, that's negative 3 squared, which is 9. Make sure you get caught up because I'm actually going to erase all that to make my room for D and E because I got a little carried away here with my writing. More time? Who needs more time? More time, okay. If I confused you a little bit, just settle in. I'm going to take my time on D. I'm going to go, let's slow this down a little bit. Teach it like I'm really having trouble with it. So if you're having trouble, here comes D a little more carefully. A little more carefully, okay? It's good? Okay, so erase all that. All this stuff. And then do D carefully, slowly, Mr. Todd. Explain it to anybody who's like, I'm lost, or you sort of fell asleep for a bit. That happens in lessons sometimes, right? Where you just sort of lose it for a second or a few minutes, or you start thinking about what you're going to have for lunch or how you're going to make time for homework tonight if you're working tonight or whatever is going through your beautiful little brain there. 16 to the negative 0.75. Okay, in order. You're going to really want this one. Again, I hope you're copying down everything, but this is one that gets the pink highlighter, a star in the column to go, this is the one. If you know how to do this one, I think you're going to find the homework goes pretty well if you can handle this situation. This is about as bad as it gets. First, the negative exponent. First, the negative exponent. I think when you see negative exponents, you should stress and make sure you know what to do with negative exponents. Here's what you do with negative exponents. That's simple. It's not easy, but that's simple. Negative exponents, just move it down to the denominator. Gone. It was in the wrong spot. That's all the reason a negative exponent appeared, is it was in the wrong spot. Now, 0.75, you say that's not a rational exponent. For once in your life, you wanted a fraction here. 0.75 is not a fraction. Yes, it is. What fraction is 0.75? 3/4. Then you're home free. So a little bit of decimal to fraction work here to challenge you on a Tuesday. Then you're home free. But I'm going to show the extra steps this time. You might be able to jump a step here once you get good at them. So this is 1/16 to the 1/4, but that gets cubed. Take the numerator out of there. That was what we were asking about earlier. What happens if it's not a 1 up there? Just make that 3 a separate power. And so now I'm 1/4√16, then cube it afterwards. If you get good at them and you can go from there to there, that's fine. But you don't have to. But if you start realizing what's about to happen here and you get faster, then that's fine. And what's the fourth root of 16?
Probably 2.
2. I love his answer. Probably 2. You know what I mean? Like a lot of these work out to nice numbers. But you got your calculator. So this is 2 cubed, which is 1 over 8.
What? Wait, so you do it like double kind of thing?
Yeah. You're going to have to, this is the root number. This is the exponent number.
Okay, so why
Root number, exponent number, top and bottom.
why can't we just add 3 to the 4 and make it like 7 squares?
They're different operations. The denominators are root.
True, that's for
The other one's an exponent, right?
Oh, but you're still like doing the opposite of multiplication.
Yeah. All right. A lot of talking to explain one simple algebraic step. Simple. Simple doesn't mean easy in algebra. Simple just means, boop, one step. This one has a negative exponent. What that means is the numerator's in the wrong spot. But also the denominator's in the wrong spot. That's what negative exponent means, is we put these things in the wrong spot. They're in the wrong numerator or denominator spot. So I'm going to write the next line, and you decide if my explanation was good enough for what's going to happen next. Watch this. So powerful. If you really know what's going on with negative exponents, you say, oh, the negative exponent means these things were in the wrong place. So in this case, the 9 comes down to be the denominator. The 4 comes out to be the numerator. It just flips, leaving some people to say, oh, negative exponents flip fractions. That's right. They flip fractions over.
So where does it go? The negative's just gone, right?
Yeah. Well, it's now built into it.
So is that a 2 over 3? You don't change that. You just change the...
This is 3 over 2. Yeah, I don't change that. I've got rid of the negative now. So what I'm going to do now is then apply the 3 halves to the top and to the bottom. That was yesterday's lesson. Remember I said you can distribute exponents? Then you can finish it off. Top is square root 4 cubed. Bottom is square root 9 cubed. And I get 8 over 27. You try and finish it off and see if you get those numbers.
Wait, no.
Did you say how did I know that?
No, because 2, wouldn't it be off?
I was going to say ancient. I'm ancient. Seen so many of these so many times, I just know. Square root of 4 is 2. Cubed is 8. Square root of 9 is 3. Cubed is 27.
Hold on there. One moment. So 2, so 4, would that be 1? The first one, right?
Square root of 4?
Yeah.
No, square root of 4 is 2.
No, I know, but I can see on the outside it says 3, right?
And then I got to cube it. So I've got a 2 inside,
Oh, that's a 2 in there.
and then cube it to get 8. Here I got a 3 inside, then cube it to give 27. If it's starting to get a little muddled on you, well, yeah, that's what the practice is for. You gotta try these out, yeah? Gotta address the homework. You're gonna have to address the homework. 2 nights in a row? No, not 2 nights in a row. 90 nights in a row from now till January. Yeah? Just get your day timer out or your calendar out and put in there 11U homework, 11U math homework. And you can just put it in repeat from now till infinity, now till January. And for you AP people, we'll keep right going. How many are in my AP? How many of you APs are, we just keep going in February? Yeah, and we'll just keep right on going. Yeah. Rinse, repeat.
Little confused with so it's like 8 over 27.
8 over 27, yep.
So the 3 on the outside, the cube, that you like multiply, so it's like...
No, I didn't multiply it. I went square root of 4, which is 2.
Okay.
Then I cubed that to give 8.
So 2 times 2.
Yeah.
Yeah, cube. So, but I thought we were still dividing, because in the other one, didn't we divide the question D, or did we? Did we not?
No.
No, we did not. We times it. Where's that? Wait. Did we divide it though? Maybe I'm missing something.
You're in better shape than you think. You're saying the right things.
Wait.
Take a whack at the homework and you'll be all right.
4/16, that's 2, and then times 2 times 3.
Not 2 times 3, 2 to the exponent 3.
Oh, no, for the other one, for D, because
4 through to 16 was 2.
and then times 3 is 8, but why is it
Exponent 3, 8.
8? Oh, because you put the 1 on top, so
Yeah, this one had a 1 on the top the whole time.
I get it.
Good stuff. Good questions. Good. Can't we just use a calculator? The answer is sometimes. Sometimes you can just get these answers by just pounding them into the calculator. So let's try that to make sure you know how to put these in your calculator. Your calculator is very wise. It can handle these messes even if they're too much for us. I'm not getting rid of all that. I'm just going to get my calculator and do these questions. 2 to the 3.5. Wrong calculator. This calculator, get rid of that one. That was period 1. 2 to the exponent 3.5. Yeah. So we're not done yet. A lot of the answers have been made to come out nice. A lot of the answers today are 2, 3, 4. That's because we're just sort of getting used to this. We're trying not to be cruel. But if it is a crazy number, your calculator can handle it. It knows what the heck's going on. So this is 11.31. I don't know what, from current slide, I don't know what decimal places we'll use all the time. But a good guess when you don't know what decimal place, how many decimal places to use, is 2. If you're not sure, use 2 decimal places equals 11.31. I'm not too worried about it. You technically should put a dot there whenever you're rounding off. So the next one, 7 to the 2/3. Try it on your calculator will do this. Hang on, I gotta go back and forth. I gotta get the calculator back on the screen here. Alt-Tab to this calculator. Okay? 7 to the 2/3. Watch this. Your calculator's ready for this. 7 to the exponent, fraction button. A couple people nodding like, yeah. You can put it right in there and go 2/3, answer 3.66 if I'm rounding. Well, it's PowerPoint with ActiveBoard with side calculator. I'm asking one too many things here of this whole thing. 3.66. I want to get it on the screen there. So from current slide, I got to be careful. It's actually partially me. I got to press the right button at the right time. Pointer options, pen, ink color. 3.66. You really should have a dot over the equal sign. Really should, to say I'm estimating. And then the last one, lots of input trouble here. Alt-Tab to get that calculator back up on the screen. Okay, watch how I enter this last one. 3/8, okay, in brackets. Okay, bracket, fraction, 3/8, bracket. Oh, mine doesn't fix the brackets until after I enter it. That's pretty cool. 3/8 to the exponent, -1/5. Look at that mess. But I'm proud of my calculator. It grinded through it. It can show it all. Can I just type these all in tonight then in my homework? Technically, yeah. But that's not where we're headed. These aren't going to be 3s and 8s and 5s. They're going to be X's and Y's and Z's and all sorts of things. We got to know what we're doing, and your calculator can't help you with that. So you got to practice with the numbers first, okay? So yes, punch them in to make sure your answers are right. But don't get addicted to the calculator. 1.22 approximately. Okay, so your calculator can handle all this stuff, no problem. Questions there? Oh, it's up there. I lost my recording button.